This is section 2.8, two variable inequalities. Okay, we are going to graph, in this video, we're going to graph linear inequalities. So in inequality, again, the reason it's an inequality is because it has less than or equal to, or it has greater than or equal to in our equations. Okay, and we are going to graph these. Now, when we start talking about graphing lines, they are going to be in slope-intercept form for you. So you have graphed this before. This is not the first time you've done this. There is one little different thing to it, and it's really pretty easy. So these should not be that too terribly bad. But it is something that you're going to want to make sure that you write down, okay, and that you can put down in your notes, because otherwise it's going to be pretty hard to figure out if you have to go back and you don't remember all this stuff. Okay, so it's going to help you to write this stuff down. Now, let's talk about how to graph a linear inequality. Now, this is a line. Okay, that's why it says linear. So we're going to take the inequality, we're going to put it in slope-intercept form. So right now, everything you're going to have is going to be in slope-intercept form. Okay, once this is done, you're going to graph that line just like we did before. You use the y-intercept first and the slope. So the very first thing you're going to do is you are going to plot the y-intercept, and then from that y-intercept you use the slope, in this case rise over run, to figure out your second point. Up, down, over, left, and right. Okay, so you use that slope to figure out your second point. And then this is the part now that once you put those two dots down, this is the part that's going to be a little bit different here. Okay, so once you got it in slope-intercept form, what you need to figure out is, first thing you need to figure out is it a solid line or is it a dashed line? How do I know? Well, if it's less than or greater than, you notice there's no line underneath these symbols, okay? If it's no line underneath, then it's going to be a dashed line. If it does have a line underneath, that means that that line is solid, or it's a solid line. Okay, so that's the very first thing you're going to need to figure out once you get those two dots on. Is it solid or dashed? Then you have to figure out, is it a shade below or a shade above? So less than and less than or equal to are always shade below the line. Greater than and greater than or equal to are always shade above the line. Okay, so these are things that you might want to highlight in your notes, circle. These are going to be the important parts. These two things right here. Everything else is exactly the same. Okay. Okay, so let's take a look here at these first two examples of graphing linear inequalities. So what is the graph of each inequality? You can see that this equation or inequality is in slope-intercept form. I know that my slope is going to be 3, and the y-intercept, or b, is -1. I'm going to always plot this point first. That tells me how much I go up or down. So I'm going to go down 1 and put a dot right there. There we go. So down 1, put a dot. Then I'm going to use my slope. My slope is 3, or 3 over 1. So that tells me I'm going to go up 3 and I'm going to go right 1 from that dot. So from this dot right here, I'm going to go up 1, 2, and 3 units, and then I'm going to go right 1 unit. So when I put this dot down, I go up 1, 2, 3, go right 1, put a dot right there. Okay, now this is where this problem gets a little bit different than your other ones previously. Previously, you just draw the line, right? And be done. Well, now I have to look at this symbol. That symbol tells me that it's greater than. Okay, notice there's no line underneath. So I got to figure out, is this line going to be solid or dashed? Well, it's going to be dashed because there's no line underneath. So when I draw this line like so, okay, when I draw this line like so, it's going to be a dashed line. So then I'm just going to take that like so, my eraser, and just take and make this a dashed line just like so. Okay, so that's a dashed line. The second part of this is that this is greater than. And because it's greater than, I'm going to shade above the line. Now, some would ask, how do you determine what's above, what's below? In this case, above is going to be this way. And I'm not going to color this on. I'm just going to draw these arrows like this to note that the shade is in that direction. What this means is that any ordered pair that you pick that's in this region right here, any ordered pair you want to pick, would be a solution to this inequality. Okay, so by putting an inequality in there, it makes it possible that there's more than one possible solution. Okay? All right, let's go take a look at the second one now. On the second one, we are going to make one change, so make sure you make this change in your notes. I want to go ahead and put a line underneath this. Okay, so in this one, my slope is -2 or -2/1. My y-intercept is +1, which means in this case, my first dot is going to be up 1 unit. So I'm going to go up 1 unit, put a dot. And then from there, I'm going to go down 2 units, and I'm going to go right 1 unit. So down 2 and right 1 from there. So from this dot, I go down 1, 2 units, and I go right 1 unit. That's where my next dot will be. So I go down 2, I go right 1, there's my next dot. Okay, now, again, I'm trying to decide, is this symbol right here, okay, is there a line underneath? There is. So this is, in this case, less than or equal to. So because there's a line underneath, I am going to make this a solid line. So it's going to be solid all the way through, just like so. Okay, and also because it is less than, that means that I'm going to shade below this curve, or excuse me, below this line. Okay, below this line happens to be down and to the left. So again, I don't need to color that all in. I just need to draw arrows showing that any answer will be in this area. Okay, so one way that I can check, I can put an ordered pair in. Notice the ordered pair 0, 0 is a solution. Okay, so the ordered pair 0, 0 is a solution to this equation. All right, now, that being said, I can test that. I can put in the ordered pair 0, 0 into this equation and see if it's really true. So I'm going to put 0 in for y, less than or equal to -2 times 0 plus 1. Well, -2 times 0 is 0, and 0 plus 1 is 1. Is 0 less than or equal to 1? That's true, yes. So therefore, the way I have this graphed out, it is a solution. Okay, so now you should be able to complete your linear inequality examples in Class Kick.